The test review, it kind of went by section, right? What section is this if you're taking d dx of both sides technically twice? 2.5, implicit differentiation. Implicit differentiation says that we can do what? Take a function and go for it, yeah. And every time you take the derivative of a y piece, what's going to be left over? A dy dx. And you can get dy dx by itself. If there are multiple dy dx terms grouping on one side, factoring out. But if they want this, what does it mean? You have to go again. You have to take the second derivative. And as you take the second derivative, you guys are seeing in the review, we'll go over questions in just a second. But as you were taking the second derivative, what ends up coming once again? Another dy dx. You can't leave him dy dx, so what do you have to do? Go back to who he was, plug it in, and then at the end of the if they give you a point, no, you can leave it nasty, plug in the numbers, and then just simplify the numbers. Or you could make it pretty if you would like, and then go ahead and plug in. Now, what if there wasn't a point? Then you would have to make it match and probably simplifying complex fractions, etc. Number 2, can you guys tell just from the beginning of the wording what section this is from? It'll help your brain categorize the problems as you come to them tomorrow. Does that make sense? Because if you can pop to a section, you can pop to a homework, you can pop to notes, you can pop to maybe even forever cards, and hopefully you can say, okay, I have a process, a procedure, a system to follow. So what section? Oh yeah. So 2.7, you should already be thinking, given, d box dt. Find d box dt. Extra clues? I don't know, I'll figure out if I need them once I'm missing stuff. Get an equation, take a derivative, plug and chug. Do you guys kind of have that set up in your mind? Given, find, picture, formula, derivative, plug and chug? Okay. I'm not going to have us go through this specific one because I want you guys to try it on your own and then go to the answer key. Some of you are already thinking about it. Oh my goodness. What's this one from? Ironically, 2.5 again. Why is it 2.5 again? Because the only legal way to solve a derivative of an f to a g, that was section 2.5 towards the end, logarithmic differentiation. What? There is no log. What do you need to do? Put an ln of both sides, because if you do ln of y, oh, implicit differentiation. Take ln, I don't have to leave y by itself. ln of y, ln of, what happens to the cosine? Pops down, product rule, now I'm going for it. But there are no y's because they actually substituted in for y somewhere along the line. Okay, what section is number 4 from? 2.6, and it's like the formula that you just had to have memorized, right? Forever card number 16. Number 5, oh, 2.7 all the way, right? And then this guy, well, he can be a little bit of everything. FRQs can just compile. It's never just one topic. But if you guys look at find the volume, oh, that's not a rate. That just says find V when H is. I think they're having me just think about a clue. But then letter B says find the rate of change of volume. D box dt, D V dt. Maybe there's some related rates in there. Okay, that's the practice test. Let's go back to the review though. The practice test, some of you, if you're bored today, you can be working on in class. If you're bored today, you can be working through your notes. If you're bored today, you can be, well, if you're bored today, maybe you're already okay for the test tomorrow. But if you're not bored today, or if you're worried about the test tomorrow, we need to talk about it. So let me pull up your test review. I have your answer key ready to go. If we have extra time, we'll go back to evens on section 2.7 because we did not get to go over very many of those yesterday. We'll go back to evens on 2.7 if we have time. That's the guy in your practice test. That's an extra guy, and then we're on the review. Okay. Oh, it was 204. There we go. All right, guys. You had the answer key that you could already have checked. So what do we have questions on, evens or odds, on the review? Yeah, David. 74. Anything earlier than 74? We're okay? Oh, was that early? Oh, it's 2B. Sorry. Got it. It's 2B. I apologize. So starting with 74. We'll do that one first. I thought you guys were like, no, we're totally good. I was like, wow. Okay. 74, the directions say, just to find the derivative. What? Is this even this section? Kind of not, but that's okay. In calculus, everything builds. I have to make sure that you don't forget stuff. How do you just find f prime of theta? 1/2 times? What's the derivative rule that I'm going to be using? E to the u. And what's the derivative of e to the u? E to the u times u prime. Uh-oh, u prime is sine of 2 theta prime. What's sine of 2 theta prime? Well, what's the derivative of the outside? Keeping the inside times derivative of the inside. So technically you have an f equals the u equals sine of v, and you have a v equals 2 theta. And his prime, and his prime. Does that make sense? Number next one. Yeah, Grace. 104. Anything before 104? 95. Anything before 95? Okay. Number 95, then number 104. Then number 95 is a word problem. Maybe I should have kept my calculator open. The speed of blood, that is r centimeters from the center of an artery. Okay, great. That's good information and all, but I have a formula. Cool. What do they tell me about the formula? dr dt is a thing at a constant distance. Ooh, that's important. Find the rate at which s changes. And then they give me like all these clues. Okay, so what am I trying to find? They actually kind of wrote every terminology language anyway, except for the find. So what's the find, guys? Rate. Careful. When you see rate, don't think r, think d box dt, right? Not given. Sorry, find. When you see rate, you gotta think d box dt. So the rate of who? S, so ds dt. Oh wait, I have a formula. Oh, can't I say ds dt is equal to, he can just step. R is a radius, and if you guys keep reading it, oh, there's a dr dt, he must be a variable. So we can go ahead and do t2r dr dt. And why am I going to say minus 0? Constant r. So each of the constants can have a derivative of 0. Oh, why did that constant say? Because it was a constant multiple. You could have also rewritten this if you wanted to be cr squared minus cr squared. And this ends up being totally constant, and this ends up being 2cr dr dt. Either way works. But what am I trying to find? This guy. When? Oh, plug in, da-dun-da-da, plug in, da-dun-da-da, plug in, da-dun-da-da, done. Plug and chug. The next one after number 95 was number, Grace, what was it? 104. I have my calculator in case you guys have any questions how to use your calculator. Otherwise, I'm not going to really stress about it as far as actually finding you the decimal answers, etc. Here he is. Sorry, Grace, I got distracted. 104, right? 104 is just find dy dx. Are we gonna get, do we have to get y by itself? Yes or no? No. Take the derivative of both sides d dx. I'm going to have negative sign of outside. Keep careful. I have to take the derivative of the whole quantity, which means parenthesis, derivative of x, derivative of y equals 1. Does that make sense? Then you have to get dy dx by itself, and we have options. I need to see how your brains work. Do your brains thinking of getting dy dx, are your brains thinking of dividing or multiplying? Everything else would be illegal. Dividing or multiplying? What do you think? Dividing? Okay. So if your brain thinks to divide, we could move this to the other side, which should be good and all, but I'm pretty sure if you're trying to make it match, they're going to write this as negative cosecant of x plus y, because that's what 1 over sine is. Doesn't mean they have to, but they probably will. And then to get dy dx by itself, subtract 1. So dy dx is equal to negative cosecant. Now, here's the struggle. This is a very valid answer, but it might not be theirs. Does it match? Ooh. No. Let me see. This is 104.
That's why I was like really confused.
Oh, it's a typo. That's weird. Our book doesn't usually have typos.
Then, like, how did they get the 1 plus sign times x plus 1 on the top?
What they did was distribute, not divide. So they distributed this to where they had a negative sine of xy and a negative sine of xy, y prime. So then they added the sine of xy, because once you distribute, then it's like an addition over here, technically a subtraction. So then they subtracted a negative, aka added, and then they divided. So they went the other way. We just said, because of what Janelle said, we just divided and said, forget it. They went ahead and distributed first and then subtracted. Ends up being the same answer because, but most of you, it would have been way harder to make this jump than it was to make the jump that I just did, because you'd have to use Hart method and do 1 over plus this over, and 1 over would be cosecant, which is why I know it's a typo, because this should not have changed. And then this over this would be 1. But yeah, thanks, Grace, for pointing out. That should be a y. I would write over it, but it's not going to work anyway, as far as saving it in there. But yeah, it should be a y. Thanks, kiddo. Okay, past 104. AJ. 119. P.S. If you haven't gotten up this far on your test review, you can be in the back of your homework spiral, right? You can be in the back of your homework spiral writing down any clues as to the questions. I don't spend a lot of time tailoring to those that are behind, but every now and then I try to give you quick ideas because I realize it's a reality. Sometimes life hits and we do fall behind. And I want you to learn how to be productive when you are behind. Y prime. Oh. I see an outer and an inner. How about you guys? You see an outer and an inner? I see a chain rule. Y prime, just take the derivative of both sides. So derivative of y is y prime or dy dx. If you need to write it out, can't we say that f is equal to tangent of u, where u is equal to, isn't arcsine just sine inverse? Okay, so what's the derivative of tangent? Secant squared of u, which is that guy, so I'll keep him, times u prime. What's his prime? Aha, do you have it memorized? 1 minus u squared, which is 1 minus x squared, times u prime of x. Got it. I'm not sure they would really necessarily simplify it much more than that. People who check their odds, are we good? And this isn't anywhere, is it? Whew, I haven't seen an 8. This is right. This is right. Use the rules properly. Here's the problem. Remember how inverse trig gives me a ratio? Gives me a ratio, goes back to an angle, and this one's asking for a ratio. It's like, wait a minute, if it gave me a ratio, I can actually use that ratio. I know it's opposite over hypotenuse because of sine. And then for secant, I want hypotenuse over adjacent. It's like, hey, if you have two sides of a triangle, you can find the third one. You can actually get me the secant squared. Little stinkers. So opposite is going to be x, hypotenuse is 1. Pythagorean theorem would get me 1 minus x squared. It's actually adjacent. So then they say secant squared, don't notation.
I won't get tricked by trig notation.
Thanks, Ryan. Secant squared, I need secant to square. Oh, well, once you have a triangle, secant's just hypotenuse over adjacent. And I'm going to have a 1/2 squared is to the 1 power 1, the exact same thing as, well, just do it this way, 3/2 power. You won't see anything like that on a multiple choice or long answer tomorrow, but does it make sense? Arcsine gives you a ratio, which is 2 sides. Pythagorean theorem says if you have 2, you can find the third. And this is just saying, who's secant so I can square him? Oh, I got it squared. Dun, 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 dun. That only happens, though, when you are looking for trig of arctrig or trig of inverse trig. Anyway, let's get away from that because that's not on the test tomorrow. But good question. Before 126? 121. Are we at to related rates? Oh, we're close. 126 might be, yeah? Okay. 121. Guys, what rule do you see? I see product rule 2, yeah? Pause. If you don't know your inverse trig derivatives, are you going to be in some trouble tomorrow? Yeah, because you're going to be wrong before you start. You got to know your forever cards, which is why we had that quiz today. You are in CalcAB. You can memorize. Just put your mind to it. Okay? I have first. I have second. So y prime or dy dx is equal to second d first plus first d. All right, cool, kids. What's the derivative of secant inverse? And every time you're saying u or thinking u, I'm putting an x because of what's in there, and then my u prime will just be 1. If it was an x squared, obviously u prime would be something different. So then we end up with, help me out, my kiddos that already did this and checked. Is that right? Some of you see the x and you're like, can't we cancel out? Can't we cancel out? The dilemma is if we cancel out, we'd have to choose a positive one or a negative one. And the dilemma is able to be positive or negative, and this always positive or negative depends. If I take that away, I'm taking away that meaning. So in this one, I have to leave both those x's. There's no way to maintain positive, negative is okay. I mean, I guess we could do a plus minus 1, but that's super awkward, and you don't know when which one is true. This way you know x is greater than 0 is going to be positive, and x less than 0 is going to be a negative. So you can't cancel that out if that was your question. Does that make sense, though? Okay, and then AJ was 126? You guys have that one too? I'll set it up. Is that okay? For 125? Linear versus angular speed, a rotating beacon. Okay, so he's rotating up 1 kilometer off a shoreline. The nice thing is they gave a picture, and I see a right triangle, don't you? How fast in kilometers per hour does the beam of light appear to be moving? It's 1/2 shoreline. Hour. Okay, so we're trying minutes to help me out, guys. They can help you out. If it's kilometers per hour, that's not d theta dt. It's some sort of measurement. We need to label our picture. We know that the beacon of light is always 1 kilometer. This is constant. Why? Picture the movement. Here's the beam, yeah? As the beam goes, is this changing? No. What's changing is theta. Theta's changing. And what's changing is also where the beam is on the shoreline. Now we do have this little dude who's a 1/2 kilometer down there. But that's going to be a such that. That's going to be a later. That's going to be a clue. Because even though the guy is down here 1/2 kilometer away, the beam of light is moving. So it's asking, as the beam of light comes to him, as it hits him, how fast does it seem to be going? Which is an awkward wording. I don't think the AP would use that wording. Kind of gross. But what's our given? Label it. Revolutions per minute? What is that talking about? Oh, nobody knows. Was the wording too confusing? We saw it in class, but maybe because we didn't write it down, it didn't stick. Revolutions per minute, it's awkward because you need to build a bridge, but you can build a bridge because 1 revolution has 2 pi radians. What is this? This is d theta d angle, how fast the angle is moving. So I could say 3 revolutions per minute is 6 pi radians per minute. All right, and that's equal to d theta dt. Revolutions always have to do with angles. Okay, so hold on. We have a theta, we have a this guy, and we have a that guy. I think I need to make this guy x. I know the guy's standing a half kilometer, but the beam's moving. It's not always at a half. So I have an adjacent, I have an angle, and an opposite. What's the only formula I can use? So this must be dx dt, such that x equals 1/2. Does that make sense? I'm going to go ahead and take the derivative of both sides. And this one looks a lot. We've done a tangent example. Was it in notes? Was it in homework? We did it in notes. I remember secant squared of theta d theta dt. I had to plug in stuff. My hint to you guys is when you get down here to do secant d theta dt equals dx dt, you're going to need things. But what you do have is a triangle with an opposite and with an adjacent, and you can do Pythagorean theorem to get the hypotenuse. So 1 squared is 1, 1/2 squared is 1/4, 1 1/4 is 5/4. So remember, don't get tricked by the trig notation. I want to square secant. How do I get secant? Hypotenuse over adjacent. So, I mean, it's going to take a little bit of creativity if you need to make it match. Simplifying a complex fraction, etc. But if it's a long answer, what did I show you yesterday? What can you do on long answers? Leave it messy. Now, hold on. Don't box it right now. What would you have to do? Plug in 6 pi and divide, but then box it. You don't have to make it pretty on a long answer. I'd rather it be right. But on a multiple choice, you're going to have to make it pretty. Yeah. Coming back to 126. It doesn't like manipulating the book with the smartboard. AJ, what picture are you looking at for 126? What did you get so far? Okay, pause. A plane's climbing. What happens when a plane takes off? Climbs. At what angle? Plane's climbing, right? Cool. It's flying in still air at an airspeed of 275 miles per hour. So it's climbing at an angle, and its speed on that angle is 275 miles per hour. No crazy vector stuff from last year. It's climbing at that speed. The plane is climbing at an angle of 18 degrees. Find the rate at which it's gaining altitude. Altitude, I think height's important. So you could put an x, you could put an h. And then we also have this guy, which we could make an x there, I suppose. So I'm going to say my given, climbing at an angle, how fast? dx dt. That's how fast the plane's going diagonally. Does that make sense? What's it asking for? The rate d who dt, rate, remember? D who dt, dh dt. Such that, does it give me a such that? No. But what does it give me? A constant. What's the formula that relates opposite with hypotenuse? Right? So couldn't we actually make life a little easier? We could actually, just on the other side, how do I take a derivative with a constant? Oh, I just leave him. You could do product rule, but when you do product rule, second d first, derivative of a constant will be 0, plus first d second. Guess what? Some of you were confused that there was no such that, but you didn't need one. X H to plug in. All you got to do is 275. Well, this is one of the few times you need to be in degree mode. And it's just for a calculus homework, not for an AP question. AP question would not have given you 18 degrees. Okay, anything else from the review? Page was related rates. Homework, section 2.7. I'm curious if we have any evens. Period 6 had a lot more questions on homework than you guys did. Are you sure there's not something else from section 2.7 after you had time to go back and look at it last night? Maybe even look at the calc chat, the evens that I showed in class. Any evens or odds you want some clarification on? AJ? 44. I think we'll have time for one more. Oh, didn't we do this one yesterday in class? Let me just pull it up then. That's what I meant. Sorry. Let me pull it up. So for number 44, I rewrote, so much easier if that's just a constant. I took the derivative, and then we were supposed to plug in. So the sides increasing, that was d what rate? Remember d what dt? ds dt. So then we would plug in 5 per second. And I have 2 times s. They said when the s is 4 centimeters. I'm actually writing in the units for a very specific reason. Then they want me to find dA dt. Oh, sweet. All we had to do is simplify. But everything's good because I have centimeters and centimeters. Figure out anything weird in number 45 that wasn't quite so nice? When we go to plug into this guy, and I think we did this right yesterday, we have 9/4, good. When we go to plug in chug, what do we have for, we didn't actually write it out, did we? A right cylindrical tank, a diameter of 3, height of 6. This could have been something where we 3 to 6 is equal to D to H sort of thing, but based on actually what they gave us, we didn't even need to use this clue, so we didn't have to use the whole similar shape idea, even though we could. Volume, find dV dt. When the water is dropping. This should be super easy, right? I mean, I didn't keep going yesterday because I'm like, guys, plug and chug. Okay, cool. dV dt is equal to 9/4 pi times 4 inches per minute. Yay, the final answer is A. Wait, they're negative? Oh, no, it's dropping. It's dropping. It's a -4. Okay, A. Nope, the answer is not A. What's the answer? D. What? The 4 is reduced. It's -9 pi. What are the units? No, what are the units here? What are the units here? Oh, guess what? The 4 wasn't good enough. I wouldn't even say it wasn't good enough. It wasn't appropriate. It wasn't ready to go yet. Things when we're analyzing, trying to look at, it doesn't actually, oh, right there, feet. They should have said, and an AP question would say, what is the rate of the volume in cubic feet? So it would have had a heads up before the actual answers. But the problem is here that the -4 inches per minute needed a bridge. What bridge would have gotten rid of the inches? 1 foot over 12. So what rate should we have plugged in? -1/3 feet per minute. Now the hard part is with all the math that we did, you missed that there's actually units here with the 3/2. The 3/2 has feet because we were using these clues from up above. So that would have been feet squared. And then once you put in feet per minute, then it's feet cubed. So some of you, if you just look at here, you'll be confused why it's cubic feet. But if you realize there's a little feet squared over here, it might make a little more sense. But anyway, sorry, quick dimensional analysis. I don't foresee that being a huge thing that shows up tomorrow, but just keep your wits about you as far as, wait, they give me inches, these are feet, I better build a bridge if it happens. Grace. 28. Is that the shadow one?
The baseball one.
Oh, baseball one from first to second? Uh-oh. Sorry, I went too far. Ah, there he is. And they give you a nice picture for this one too, but I can do it fast. First to second, at a speed of 25 feet per second. So I draw the picture. Pretend that's even. Oh dear. Second, there's first. I might not give you a picture tomorrow, so if you're not very familiar with baseball, you might want to just study the picture. Going from first to second, little player is here somewhere. Distance from home. Yes, it does. That's changing as the player runs. I can label him C. This is changing as the player runs. I can label him A or B or whatever you want. But what am I going to label this with? Sorry, it's from an old problem. I'm going to label it with 90. You might have remembered that. You might not have remembered that. Because what happens as the player runs, what doesn't change? Remember, you can plug in any constant early. So my formula is just going to be an a squared plus 90 squared equals c squared for me to derive in just a second. But my clues for my given, do you guys see how there's a pattern? There's such a pattern, right? So what rate do they give me? Well, it's 25 feet per second, and what is it? How fast the player is running from first to second base. I'm calling it a positive because this distance from first is growing as he runs. I'm not using this one because that's not a right triangle, and the formula would be way harder. It'd be law of cosines. Blech. And then it says find the rate at which the distance from home plate. Well, what did I label that? See. Such that the player is 20 feet from second base. What does that mean as far as his A value then? That's where a lot of people would have messed up. The 20, how is, the whole thing is 90, that's 20, so it must be 70. That's the clue you want to plug in after you take a derivative. Taking a derivative, 2a dAdt equals 2c dCdt. Oh, wait, pause. I don't have enough. What are you going to do if you don't think you have enough? Take a breath first, right? Take a breath first and then be like, I can do it. They gave me enough information. The A is easy. That's going to be 70, right? The ADT is going to be easy because that's 25. Wait, check your units. I have feet and feet. Whew, good. Equals 2. Has anybody figured out where to look if you're missing something? Usually the first place to go looking. If I know A, what can I do to find C? Plug it in, plug it in. If you know A, you can find C. So C is going to end up equaling the square root of 49 and 81, 120, 130. $490 and 8100. No, 8100. Sorry, my zeros might be wrong. I'm just going to be a lazy bum. I'm going to be a lazy bum because you could do this tomorrow. Because I'm not planning on letting you use calculators tomorrow. Bring them just in case. Just in case there's a decimal one. I'm like, okay, fine, I have to let you use it. Bring your calculator just in case. But otherwise, I'm going to say don't use it. Like if there's not a decimal one, I'll say don't use it. Why? Because you can leave me gross things like this. Because they'll be in the long answers. Okay, anything else from the test review or section 2.7 that I can answer for you? Which one? 29? Oh, now we get to the data one. It's a great question, Rachel. I just really wish it was yesterday or earlier today. The shadow problem, just a quick heads up. The shadow problem is great. The shadow problem is great for the AP. Not so important for the test. Did you guys hear me? The shadow problem is great for the AP. Not so important for the test. Which means, do you have to stress about shadow for tomorrow? No. Okay? In case that was a concern. Okay. So for number 29. You guys have the picture up above of the guy walking away from the light post. Long story short, the trick is talking about the tip of the shadow and talking about the length of the shadow. If you were to draw this picture, there are a few things that we could label, like this is always 6, the guy's height doesn't change as he walks, and the lamp post is always 15 feet, that doesn't change. I could label this as X, and if that's X going to the tip of the shadow from the light post, this is looking for, letter A is looking for dx dt. It also talks about how far away he is from the light post, so that could be Y. And for letter B, this could be X minus Y. So the ironic part of this one is it's actually looking for dx minus y dt, because it's talking about the length of the shadow changing. And the key to this is similar shapes have proportional sides. So we can say 6 to 15 is going to equal x minus y to x. Yeah, took me a second. Some of you might like the picture just a little bit better if you rearrange this and don't label it like that. For instance, you could go ahead and make this whole thing x. You could make this y, just to make it a little bit prettier. This will probably be the easiest way to go about it. dy dt. That's prettier. And then this could be y over x. So 6x equals 15y is what you'd want to take the derivative of, and this piece would be x minus y. I think that's easier. So take the derivative of that piece, plug in that piece. Kiddos, I'm here, but not available during lunch. I'm here and available during 7th period and after school until about 4:30. Probably 4:30. Probably 4:30. Wait, test tomorrow. Sorry. Come early. Sorry, you guys know the drill. I should have announced it. I apologize. Logistics. Notes updated. Homework Spiral's ready to go. Phones in the and we can start at 7:50. Come at 7:45. I'm sorry, guys. I was trying to answer questions and forgot logistics. Spread the word to the few like Nick Hartonian who left.